Hello, for homework set number 4B, I chose number 4, which states in 1996 NASA performed an experiment called the Tethered Satellite Experiment. And this experiment, 1.4 times 10 to the 4 meters length of wire was let out by the space shuttle. So that's the wire. And the space shuttle Atlantis to generate a motional EMF. The shuttle had an orbital speed of 7.45 times 10 to the 3rd meters per second, and the magnitude of the Earth's magnetic field at the location of the wire was 4.63 times 10 to the negative 5 Tesla. If the wire had moved perpendicular to the Earth's magnetic field, what would have been the motional EMF generated between the ends of the wire? So for this problem, it's demonstrating that so we're perpendicular, and that's because our B is going up, and then our rocket is actually going east to the right. So let me just explain what B is. B is the magnetic field. It is a vector that demonstrates the strength and direction of a magnetic field. Its SI units is Tesla T. And then also what we need to know for this problem is that E, or this like weird E, is magnitude of motional EMF, which would be induced potential, and it is a voltage of the magnetic field, which causes a current. The SI units for this is voltage, which is also known as just V. And then the L is length, and it's a measurement of distance from one point of an object to the other point. Its SI units is meters, M, so we have to know L for our length of the wire, which was given in this problem. And then V is velocity. Its SI units is meters per second. It is a vector that demonstrates how fast the particle is moving. So for this problem, I have drawn the rocket. It's moving east. And then this B, which is a magnetic field, would be going north, or it'd be going upward to make it perpendicular to wherever this was traveling. And then it's saying that it's traveling at 7.45 times 10 to the 3rd meters per second. And then it wants to know what would have been the motional EMF generated between the ends of the wire. So we're overall going to be solving for this this E. So we just have to plug in those problems. So I used this equation that was given in the book, and the equation given in the book is the E equals VBL, but it states that it just ignores sine theta since we're mutually perpendicular. Sine theta cancels out, which would be 90 degrees. Sine 90 would cancel out to 1, so they don't include that, but I wanted to include that just to show that makes sense. So I plug in what I know, which would be my velocity would be 7.45 times 10 to the 3rd meters per second times my sine theta, which would be sine 90, which cancels out to just 1, and multiply it times our B, which would be 4.63 times 10 to the negative 5 Tesla, and then times our length, which would be 1.41 times 10 to the 4th meters. So our overall magnitude of motional EMF would be 4.86 times 10 to the 3rd volts. And that's what I got up here also. So thank you.